So you have, I will rewrite this expression IC1 by IC2 equals e to the power Vd by Vt. Now we know that total current IQ is equals the sum of the emitter currents. So that is the total current that is equals to the sum of the emitter currents, and we can replace emitter currents by collector currents IC1 by alpha plus IC2 by alpha. If I take common of IC1 by alpha, it will be 1 plus IC2 by IC1, or you can write IC1 by alpha into 1 plus, so you know this ratio, so we already derived this ratio, so e to the power, so it is IC2 by IC1, so there will be minus sign, exp minus Vd by or from this expression you can find IC1. So IC1 equals alpha times IQ divided by 1 plus e to the power minus Vd by Vt. So in similar way, if I follow the same exercise and common IC2 and replace the expression here, we can achieve the result IC2 equals alpha times IQ divided by 1 plus exp e to the power Vd by Vt. Notice here, so that is minus Vd, in this case it is plus Vd. Now we shall try to plot these two currents. We shall plot these two currents IC1 versus Vd and IC2 versus Vd. So as you can see, we divide our Vd axis by Vd, 2 Vt, Vt, 2 Vt, 3 Vt and 4 Vt. In this side you have minus Vt, minus 2 Vt, minus 3 Vt and minus 4 Vt. And we are plotting plotting IC1 and IC2 with respect to Vd. As you can see from the expression, by looking at the expression, you can see that IC1, if I increase Vd, so in this axis, if I increase Vd, this expression will be will have less value, so denominator will have less value, so as a result IC1 will increase. So that curve is corresponding to IC1, that is corresponding to IC1, and that curve is corresponding to IC2. At this point, you see it is midway of these two curves. The maximum current, if one current is 0, so in this point you see, in this point IC2 is 0. So as a result IC1 will have IQ. This current will be IQ. So actually not IQ, it will be alpha times IQ. It will be alpha times IQ. So IC1 will reach at alpha times IQ current whenever IC2 is 0. So around 4 VT, around 4 times VT, IC1 will achieve alpha times IQ amount of current, and IC2 will be 0. And at this point you see input voltage is 0. So as a result both IC1 and IC2 will have the same strength of current, which is alpha times IQ by 2. And for IC2 you see same explanation will be valid. Now as you can see that within this range 2 VT, within 2 VT to minus 2 VT, 2 VT to minus 2 VT, you can see these curves are almost linear. So these curves are almost linear, that is almost, you can say, straight lines, these two curves. So between minus 2 VT to plus 2 VT, within this range both these amplifier transistors will act as in active mode. As a result these regions will be used for amplifications, and you see in this region it will be behaving as a switch, because one is having higher current and that is almost zero current. That is the behavior of the switch. So one output will be high, another output will be almost low. So that's how the differential amplifier will work, and we'll use the differential amplifier. We'll keep VD, it should be less than, it should be greater than minus 2 VT, and should be greater than less than twice VT. So in this region this differential amplifier will act as a linear amplifier. So in this region this differential amplifier act as a linear amplifier.